We'll go over 3 questions in hypothesis testing by following these 4 steps. 1, determine the null hypothesis and alternative hypothesis. 2, we have to determine the critical value and choose a tail. You have to choose the tail first, by the way, whether it's a two-tail or a left tail. And 3, we will have to calculate the test statistic, which is usually the z-score, or it could be a t-score if you're using the t-distribution. And 4, we'll make a conclusion. In addition, we'll also look at the p-values. So this first question, if a company is buying 25 wine bottles but is suspicious that they're getting something that's less than 25, so what do? They take 10 bottles and make measurements, and they get the sample standard deviation of 0.9. And you have to use the 0.05 significance level to conclude whether or not the average fluid volume of the bottle is less than 25 ounces. Okay, so one thing that you have to do before going through the 4 steps is to look at the sample size and see if you have the population standard deviation or not. In this case, you only have the sample standard deviation, right? If the n is less than 30, and also if the population standard deviation is not known, then you have to use the t-distribution. In other cases, you have to use the normal distribution. Okay, so you want to make sure that you know which distribution to use, either the normal or the t. Here we have to use the t. Whenever you're using the t-distribution, it's good to first write down the degrees of freedom, because degrees of freedom for the t-distribution is defined as n-1. Normal distribution, you don't have to do this, but degrees of freedom is needed for t-distribution. In our case, sample size is 10, so you're going to get 9. Okay, now let's discuss what the null hypothesis and the alternative hypothesis is. The null hypothesis is like the saying innocent until proven guilty. So it's like the status quo. There's nothing wrong, nothing strange is happening, and H1 is saying, oh, somebody's guilty or something strange is happening. Okay, so in this story, the store won't be guilty if the average is indeed what's labeled as 25, right? Whereas the store will be guilty if they're selling something that's less than 25. However, when you make these null and alternative hypotheses, you have to make sure that the two things are direct opposite of each other. See, the opposite of being equal is not equal, and opposite of being less than should be greater or equal to. So you see that they're not directly in opposite of each other. In that case, go back to the question and figure out what you're really trying to prove. Are you trying to prove that average is not equal to 25 or less? Well, if the average indeed turns out to be bigger than 25, then the store did nothing wrong. So so I think this is what we want to show, right? So you have to modify the null hypothesis as the opposite of this one, which is greater or equal. Okay, so we are going to put greater or equal here. Now let's do the step 2, which is to determine the criteria. So you want to draw the t-distribution, and it's just a bell curve, just like the normal. It's supposed to be slightly more spread out, but I can't draw that. So it's just the bell curve, and you're trying to say that because you're trying to show that something is less, your tail is in the bottom, the left tail. That's what you're trying to use, okay? Because the alternative is less, or put it this way, if the quantity is strangely low, then you can accuse the store, right? So if it's in this 0.05, that's the significance level, right? If this area, shaded area 0.05, contains our test statistic, then you can accuse the store of selling wine that's not reaching 25. Okay, So we also need to know this critical value. What is this boundary? Well, to do that, you want to use a calculator. So let's use the TI-84. And you want to use the inverse t because it's a t distribution, right? And because you have 0.05 as the area and your degrees of freedom is 9, you calculate and you get negative 1.833. Okay, so you have to say that this is negative 1.833 because, which is equal to the inverse t distribution of 0.05, your significance level alpha, and the degrees of freedom 9. Okay, so now let's move on to the test statistic. You find a z-score as x bar minus mu over sigma over square root of n, right? In our case, it's not the z-score, it's the t-score because we're using the t distribution, but the formula is the same. The x bar, which is the mean value of the sample, minus the mean value of what's claimed, the average of the null, so you use 25, and you divide it by 0.9, the standard deviation, divided by the square root of the sample size, which is 10. Now when you put this into the calculator, let's see, this minus this will be 0.7, right? When you put this into a calculator, it's important to have a parenthesis around this bottom because if you don't have it, the calculator will think that you first do 0.7 divided by 0.9 and then divide that quantity by square root of 10, and that's actually different from what this is claiming, okay? Because the order of operations here is that this is just one single number and then you're dividing this by this. So make sure that you don't forget that parenthesis. Let's use the calculator to calculate this. So you have 0.7. Actually, that's a negative. I forgot to put a negative there. So it's negative 0.7. So it's negative 0.7 divided by, you have to open a parenthesis, 0.9, and then divide again by square root of 10, parenthesis, and then enter. You get negative 2.46, something like that, right? So that's negative 2.46. Well, now this is what we call the test statistic. And this test statistic actually lies in the shadowed, the shaded region. Okay, so so this, we see that negative 2.46 is in the left tail. And finally, we can conclude saying that your conclusion is that the null hypothesis is rejected, and the store is selling wine less than 25 ounce. That's our conclusion. Okay, that's your H1. So this is your conclusion. Okay, this is adapted. All right, so let me just say a little bit more about the p-value. The p-value is the way to measure how serious is this claim that H1 is true. And It depends on the tail. In our case, it's the left end tail. So you choose here negative 2.46, and the p-value is the area of this tail that's divided by the test statistic that you just came up with. So our test statistic was negative 2.46. So the p-value would be this area. Well, that'll be like the cumulative distribution of the t. Remember, this is a t distribution, so we'll have to use second vars of t CDF, and the first one is negative infinity, and the upper is negative 2.46, right? And our degrees of freedom is 9. So if you paste this, you get 0.081. Okay, so this is 0.081, or actually 0.0181. Sorry, should be 0.0181, which is like 1.81%. And this is saying that if H0 is indeed true, there's only 1.81% that you would have this kind of sample. So it's a much more stronger way to say than with the 95% significance level. You're rejecting the null hypothesis. And there's also another thing that the p-value tells you, which is that we see that if we were to use the 0.01 significance level, we wouldn't have been able to reject this H0 because this is bigger than the 1%. Okay, so let's do the next question. Here's next question where you have to do some research about the adult male. The conventional view is that adult male consumes 2,500, but you're not sure. The manufacturer wants to change according to the changed calorie consumption of the customers. So they take a sample of 50 adult males, and they find that the average is 2,655 calories and standard deviation is 280. And you want to use a 0.01 significance level to see if it's changed or not. Okay. All right. So here, because 50 is bigger than 30, we just use the normal distribution, not the standard one, not the t distribution. We use the standard normal distribution. And then the H0 would be saying that the average is equal to 2,500, and the alternative is no, we don't think so. Maybe there's something going on. We need to change the way that we make our frozen food, right? Okay, so for this, make sure that they're direct opposite of each other. And look, indeed, the company is not sure whether the average calorie is bigger or smaller. In either way, they have to adjust, right? So what they really want to show is that the average is not equal to 2,500. Always make sure that your null and alternative are direct opposites. Okay, let's now move to step 2, which is to draw the normal and then figure out what to do. Well, for not equal, you need the two-tail test. And because the total sum of the tail area should be less than your alpha level, 0.01, that means this part should be 0.005, whereas this one should also be 0.005. That's the area, okay? To find this critical value, what you need to do is now inverse norm. So let's use the second vars inverse norm. and the area is 0.005. Enter, enter, and the result is negative 2.576. Okay, so negative 2.576 obtained by inverse norm of the alpha divided by 2. Okay, we have to divide by 2 because it's a two-tailed. Now, you should also figure out what this is, but we know by symmetry, if this side is negative 2.576, this side must be the positive 2.576. Okay, so we now have a criteria. Now let's look at the z-score, our sample statistic. And you have to do the average of your sample minus the average of what H0 claims, divided by the standard deviation, 280, and then you divide it by square root of the sample size, which is square root of 50. And let's calculate this with a calculator. And again, the parenthesis is very important. So parenthesis 2655 minus 2500, and then parenthesis divided by, and again open a parenthesis, 280 divided by second, so use square root of 50, and then you close the parenthesis, enter, 3.914. Okay, that's a really big value, 3.914. And as you can see, that belongs, so here, this belongs to this tail, 3.914. Okay. Therefore, we can step 4, we reject H0, and we can conclude that average adult male daily calorie intake is not equal to 2,500 calories. Okay, so that's the answer. And again, let me add something about the p-value. What about the p-value? Well, in the two-tail case, when you have this place bounded by 3.914, you want to actually double it, because the p-value will be the sum of the two tails that's bounded by 3.914 and the minus of it. Okay? So we will need to double the value, and because the CDF function, cumulative distribution function, is set to integrate from or calculate the area from negative infinity to this value, it's easier to just put the minus one as the area and then double that one. Okay, so let's try this one. We're going to do second vars, go to normal CDF, and change the upper as 3 point, actually not the positive one, let me delete, should be negative 3.914, and then you want to multiply the above by 2, and you get 9.08 10 to the negative 5. Okay, so p-value would be 9.08 times 10 to the negative 5, and what this simply means is how many zeros to put in after putting the 0 dot. Okay, so 0 dot, actually 1 minus this one. So if you have 5, you put 4 zeros, 1, 2, 3, 4. If this is 4, then you put 3 zeros, and then 908. Okay, And because this is such a small number, it's much less than 1%, right? So you can kind of say that it's highly unlikely that the calorie intake is 2,500. That's a p-value. Okay, last question. This last question, since by now you kind of know what this business is about, I just made a question without doing any context. So here the population standard deviation is known as 2.1. Sample mean of 10 samples is 13.5, whereas its hypothesis that population mean is 14.2. So because you're deciding whether the mean is 14.2 or not, these will be your null and alternative hypothesis. Also, although you only have 10 samples, because the population standard deviation is known, you still use the normal. And then because it's not equal, you still use the two-tailed test. And 0.05 significance level, you would need to go and calculate the second Vars inverse norm of 0.05 divided by 2, because it's a two-tailed, and that's negative 1.96 on the left side. So this will be negative 1.96 on the left side, and this will be positive 1.96 on the right side. Now the z-score would be sample mean minus the no, that's the population mean. The sample mean is actually 13.5, and the claimed population mean is 14.2, divided by the population standard deviation over the sample size square root of 10. Let's put that into a calculator as well. So you have parenthesis 13.5 minus 14.2, close the parenthesis, divide, open another parenthesis, very important, it's easy to forget this parenthesis, 2.1 divided by the square root of 10, and then close, and you have negative 1.054. Negative 1.054. Okay, so in this case, this does not belong to the shaded area, right? So negative 1.054 is somewhere here. So this is somewhere here, negative 1.96 and negative 1.054. Okay, so it's not in the shaded region, therefore we cannot reject H0. So again, it's innocent until proven guilty. We're not saying that the population mean is 14.2. We're just saying that we don't have enough proof to show that the population mean is 14.2. Okay?